The Perseids. Every August, many of us look up to see the Perseids, what we call shooting stars. But what if I told you this isn't a gentle light show, but the scene of a high-speed collision between Earth and the dusty ghost of a giant comet? This annual spectacle is a beautiful reminder that we are drifting through a cosmic field of ancient debris, left behind by an object some have called the most dangerous object known to humanity. The celestial parent. To understand the Perseids, we first need to talk about their parent, a colossal comet named Swift-Tuttle. This isn't just any icy rock. It's a 16-mile wide giant on a 133-year journey around the Sun, stretching from beyond Pluto to just inside Earth's orbit. Every streak of light we see is a tiny, frozen piece of this majestic wanderer, a story written in fire across our sky. Who is the parent of the Perseids? Imagine an ancient celestial dragon, sleeping for a century as it drifts through the cold darkness beyond Pluto's orbit. As it awakens and flies closer to the sun's warmth, it sheds glittering scales of dust and ice, creating a river of cosmic memories that flows through space. Earth just happens to sail through this shimmering river of debris, the legacy of Comet Swift-Tuttle, every single August. Is this cosmic parent a threat to us? Think of it like this. The comet and Earth are two trains on tracks that cross, but they are running on a strict timetable, and their schedules won't have them at the crossing at the same time for thousands of years. While an impact from the most dangerous object known to humanity would be like a continent-sized freight train hitting a bicycle, the tracks are clear for the foreseeable future. For now, we just get to admire the harmless sparks it left behind on the rails. How was this cosmic connection first discovered? The discovery was a brilliant piece of celestial detective work by the astronomer Giovanni Schiaparelli in 1866. He calculated the orbit of the Perseid meteoroids and realized it was a near-perfect match for the orbit of the newly discovered comet Swift-Tuttle. It was the first time a meteor shower was ever definitively linked to a specific comet, proving these shooting stars were not atmospheric phenomena, but visitors from deep space. Anatomy of a light streak. Now, let's break down what's happening in that fleeting, fiery moment we call a shooting star. This isn't just a random flash. It's a story of incredible speed, intense energy, and chemical reactions playing out high in our atmosphere. The science behind this anatomy of a light streak reveals the secrets of what these cosmic visitors are made of and the violence of their arrival. What exactly is a shooting star? Think of a Perseid meteoroid as a tiny, icy grain of sand that has been traveling for centuries in the frozen vacuum of space. When it finally smashes into Earth's atmosphere at 132,000 miles per hour, it's like a microscopic spaceship making a final, suicidal plunge. The sheer friction and compression of air in front of it creates an intensely hot, glowing plasma trail, which is the brilliant flash we see. What is the difference between a meteor, meteoroid, and meteorite? It's a story of a journey and a destination. A meteoroid is the traveler, a small rock or piece of ice wandering through the solar system. The meteor is the spectacular journey's end, that fiery streak of light we see as it burns up in our atmosphere, while a meteorite is the rare survivor, the one piece that actually makes it through the inferno and lands on Earth's surface. Why do meteors have different colors? Those colors are the comet's chemical signature, a final, vibrant message from its core. As the meteoroid vaporizes, its atoms interact with the atmosphere, creating a unique light show based on its composition. Sodium atoms glow a brilliant orange yellow, iron gives off a golden hue, and magnesium paints a beautiful blue-green streak, while Earth's own atmospheric nitrogen and oxygen can add flashes of red. What is the radiant point of the shower? The radiant point is an illusion of perspective, much like standing in the middle of a long, straight road and seeing the edges appear to meet at a point in the distance. All the Perseid meteoroids are traveling in parallel paths as they strike the atmosphere. But from our viewpoint on Earth, they appear to diverge from a single point in the sky. For the Perseids, this point happens to be in the constellation Perseus, which is how they got their name. How is the intensity of a shower measured? The zenithal hourly rate, or Z-char, is a standardized, perfect score for a meteor shower, assuming you are in the darkest location with the radiant directly overhead. Think of it like measuring rainfall. The official report might say an inch of rain fell, but your personal rain gauge under a tree might only catch half an inch. The Z-char for the Perseids is about 100, but light pollution and the radiant's position mean a typical observer will realistically see 40 to 60 per hour. The unsolved puzzles. It's easy to think that an event as predictable as the Perseids is a solved problem, a celestial show we have completely figured out. But scientists are discovering that the more closely they look, the more unsolved puzzles they find hidden within a shower. These mysteries suggest that the river of debris we fly through each year is far more complex and dynamic than we ever imagined. Why do meteors sometimes appear in bunches? The debris stream from Comet Swift-Tuttle isn't a uniform cloud. It's more like a cosmic river with currents, eddies, and dense rapids. These meteor bunches happen when Earth passes through a thicker, clumpier filament of debris, likely herded together by the immense gravity of Jupiter over millennia. So instead of a steady trickle, we get sudden, intense bursts of meteors, followed by moments of quiet. What causes the exceptionally bright fireballs? The surges in fireballs are one of the most exciting mysteries, suggesting we are occasionally flying through a cosmic treasure chest. These are likely dense filaments within the debris stream that are packed with larger, pebble-sized, or even fist-sized meteoroids. When these bigger pieces burn up, they create exceptionally brilliant flashes of light, briefly outshining the brightest planets in the sky. What are the ghostly trails some meteors leave behind? A persistent train is the glowing, ethereal ghost the meteor leaves behind, a haunting signature that can hang in the sky for seconds or even minutes. It's not smoke, but a trail of ionized air and vaporized meteoroid material that is still reacting chemically. This beautiful, eerie glow is a visible echo of the meteor's violent passage through the upper atmosphere. What creates that lingering glow? That lingering glow is caused by a process called chemiluminescence, which is essentially light created by chemical reactions rather than heat. Imagine a firefly's cold light. It's a similar principle, where the energy from new chemical bonds forming in the meteor's wake is released as photons. The exact, complex reactions involving sodium, iron, and atmospheric atoms are still an active and fascinating area of research. A guide for the stargazer. Now that we understand the science and mystery, let's talk about how you can experience this cosmic show for yourself. You don't need a PhD or expensive equipment to have a profound connection with the cosmos. With a few simple tips, this guide for the stargazer can help you turn a casual glance at the night sky into an unforgettable celestial adventure. How can someone best watch the Perseids? The absolute best way to watch the Perseids is to treat it like a trip to an outdoor cinema, where the screen is the entire universe. Get as far away from city lights as you can, lie down on a blanket or reclining chair, and simply look straight up, taking in as much of the sky as possible. Put your phone away for at least 20 minutes to let your eyes fully adapt to the darkness. Patience is the secret ingredient. How can you capture a meteor with a camera? Photographing a meteor is like fishing in a cosmic river. You can't aim for a specific fish, so you must cast a wide net and be patient. Use a camera with manual controls, a wide-angle lens, and a sturdy tripod. Then set it to take hundreds of continuous, long exposure shots of 15 to 30 seconds each. Eventually, a meteor will swim through your frame, and you'll have caught a streak of celestial light. A mirror to humanity. For as long as we've looked at the sky, we've told stories about what we see, and the Perseids are no exception. This meteor shower acts as a mirror to humanity, reflecting our greatest hopes, fears, and our unending search for meaning in the cosmos. From ancient omens to modern conspiracies, the way we interpret these falling stars says more about us than it does about them. How did our ancestors see the Perseids? Before science, our ancestors saw the Perseids not as debris, but as powerful, divine messages written across the heavens. Imagine being an ancient farmer or king, seeing the skies suddenly filled with fiery tears or streaking spears of light. These events were often seen as omens, foretelling the death of rulers, the outcome of a war, or the pleasure and displeasure of the gods themselves. What is the story behind the Tears of St. Lawrence? The legend of the Tears of St. Lawrence is a beautiful fusion of faith and cosmic timing. St. Lawrence was martyred in Rome on a grill on August 10th, 258 AD, right near the peak of the Perseid meteor shower. Over time, folklore connected the fiery streaks of light in the sky to the fiery tears of the martyred saint, falling to earth on the anniversary of his death. The future encounter. As we look to the future, there is a spectacular celestial event on the horizon that is already marked on the calendars of astronomers worldwide. The return of Comet Swift-Tuttle is not a question of if, but when, and its next pass promises a truly unforgettable show. This future encounter will be a powerful reminder that the solar system is a dynamic and ever-changing place. What will happen when the comet returns in 2126? When Comet Swift-Tuttle returns in 2126, it will be a spectacular sight, easily visible to the naked eye as it graces our night sky. In the years immediately following its pass, Earth will plow through the fresh, dense trail of debris it leaves behind. This will likely trigger a magnificent Perseid meteor storm, with rates potentially reaching hundreds or even thousands of shooting stars per hour, a celestial fireworks display for a whole new generation.